first we will revise whatever we have discussed in the last class. Then we will start our today's class. We have seen in the last class we have started from CO detector. CO detector, we have seen there are detect what PS detector. PS detector, we have started from the detector where the silica gel impregnated with the light yellow potassium palladium sulfate. Multi-gas detector Hopkelite we have seen. We have started from the PS detector where we have seen that the air up to 120 centimeter cube air in 2 minutes constant rate we flow from the this instrument. And it is like a tube where the both side the silica gel is present, and the yellow potassium palladium sulfide color change in the brown color, and range is the 0.005% to 0.12%. We consider if we are taking the PS detector. And another instrument or a detector for the carbon monoxide CO, which we what is Hopkelite detector do? It convert our carbon monoxide into the carbon dioxide. Okay, and in the Hopkelite detector we use manganese dioxide and copper oxide. And because carbon monoxide convert into the CO2, temperature will be increased. So for measurement of the temperature we use the thermometer, and the range for the carbon monoxide for the Hopkelite will be 0.05% to 0.005% to 0.0015%. Then we have see the holemite tube. In the holemite tube, the iodine pentoxide and sulfuric acid we take, and it will convert if our in the holemite tube when air pass, and if you see the CO is present in the desired range, or in the range which holemite tube works, it convert and its color will be convert, and it will show an green, brown, or black color. Then we have seen the Draeger multi-gas detector. Like its name, multi-gas, that means it is used for carbon monoxide, but also it is used for other gas like the H2S CO2, H2S CO2, that means carbon dioxide, methane gas, that means CH4, and ethylene. And its carbon monoxide range will be up to 5 ppm, and it give us the reading within the 1 to 2 minutes. Then we have seen MSA detector, which have the color scale and carbon monoxide detecting tube. For the MSA detector, the range would be the 10 ppm to 1000 ppm. And in the MSA detector, the chemical use yellow silica gel, palladium sulfide, ammonium molybdenum, and it will change its color into the green color. Then we have seen the Emicor's carbon monoxide detector and monitoring system, which range will be the 0 to 50 ppm. And sometime, so one of the value handheld instrument has, it is the handheld instrument, and it has also a alarm when the desired range achieve. Not, you can not say desire, but if the range of the carbon monoxide reached, the alarm will beep, and the continuously monitoring it give you the continuously result. And if it alarm and beeping or blink, so if the normal time it is blinking in 50 second per blink, then when the range of the CO presence, it will blink in 1 second per one blink. Then we have seen Ultron India Limited, which have the two model BCO1, BCO1R, and it is the electrical supply as well as battery operator. So uh, if in the mines the electricity power cut off, then it will show the result uh, based on your battery, because it is also operated on the battery also. And it is all water and dust resistance, so you can use in the various in situations. Then we have seen gram ratio. That means gram ratio is CO produced divided by oxygen consumed into 100. I told you to remember this formula, because after this theory section tomorrow, I think we will start our numerical of the ventilation. So please remember the gram ratio, which means CO, that means carbon monoxide produced divided by O2 consumed. I also told you to remember the O2, which exact value 20.93. If you want to write, remember, O2 is 20.95. And for nitrogen you should remember 29.02. Please remember these information, so it will help you to solve the numerical. And I told you also that gram ratio, if the range in the 0.1 to 0.5%, and normally in the normal coal mines you will you will find this range 0.1 to 0.5%. But if the gram ratio is showing 1, the ratio is showing 1, then it is the indication of the spontaneous heating. And if the gram ratio percentage will increase up to 2%, that means the active fire chances will be increased. That means the advanced stage of approaching toward the active fire. If the gram ratio, if you are getting 3%, that means this is the indication of the active fire. I told you ventilation of the mines, that CH4 in the written airway 1.25, any part 0.75. Weight bulb temperature should be less than 33.5 degrees Celsius. And O2 percentage should not less than 19%. CO2 percentage should not less more than 0.5%. And I told you to remember these information, because I have seen lot of question based on this information, that uh, for the person calculation in the district on the largest shift. I think you don't have asked me district on the largest shift. Means if some of you have confusion, that suppose you have three shifts, one, two, three shifts. So in the first shift you have 200 people, and in the second shift you have 220 people, and in the third shift you have 210 people. Okay, 210 people. So which data you have to take? You have to take 220, because if the air is sufficient for the 220 people, 220 people, that it is the common sense that it will also sufficient for 200 and 210, because they are lesser than 220, है ना? So we have to take the largest shift value. Okay, and so 6 meter cube per minute per person. And for the ton calculation you have to multiply 2.5 meter cube per minute per ton in daily output. Okay, and here I have given you basic information, but maybe you have not focused. So air current should, देखो, in normal environment you need 1 meter cube per second हवा चाहिए ना, that much air you need. But if the temperature is more than 30.5 degree, then you need more than 1 meter cube per second. Just remember. Or then we have seen there are various apparatus instrument, that is thermometer, Fahrenheit. Then we have seen barometer. Then we have seen 14 barometer, Android barometer. I told you better than the mercury thermometer does not contain any liquid in the Android barometer. It work on the Boyle's law Then we have seen the hygrometer, relative humidity. We have talked about here. That is, what is the relative humidity? Mass of the water vapor divided by mass of the water vapor required to saturate it. Normal body temperature we have seen, but it is a normal GK question, maybe you know or not. So then we have seen the relative humidity formula, 100 minus dBT minus dBT. I told you dBT, that means dry bulb temperature, which is dBT, and WBT, that means wet bulb temperature. Okay, multiplying factor, if the temperature is more than less than 20 degree, you have to take 9%, and if the temperature is between 20 degree to 25 degree, that you will take 8%, and more than 25 degree, then you have to take 7%. And we will see question based on this formula, so don't worry on that. Kata thermometer. Okay, so if still you have any doubt regarding whatever we have discussed, please comment, so we can discuss your queries. Please comment if you have any doubt, then comment, so we can take your questions. Otherwise, today we will start AK Gorai remaining parts, and today we will try to finish velocity of the air. Just you need, for your numerical section, you just need what information you need, I will let you know. So for suppose person, because in the your underground there are men and machines. Okay, men. So men and machine and men try to produce coal or metal, anything, coal. So we are talking about coal here. So we require air for men as well as coal, because if you don't provide air, your men can be die. And if air is not up to the mark, you will face spontaneous heating or active fire. So for the main calculation, he will give you that in the first, second, third shift, you have 300, 450 people, and 250 people respectively, and your daily output is 3000 ton. Okay, so you have to take largest shift, that is 450. So 450, forget about anything else. And this is for the persons. And for the production, daily production, you have 3000 ton. Now you have to calculate the, so I told you 6 meter cube per minute for one person. So you have 450 people person. And I told you to remember 225 meter cube ton, it is per ton, but you have production of 3000 ton. So when we add both of them, from this calculation we will get our answer. And when we see the question, we will see lot of question based on, just remember, for the person calculation you will need 6 meter cube per minute, and for the production you will need 2.5 meter cube per minute. ज़्यादा क्लियर है ना, क्वेश्चन में ही होगा. Okay, today we will start. Okay, the I told you the temperature should not more than 33.5%. Just we have to start our topics, and then we will take your question if any. Okay, so today we have to cover remaining part of AK Gorai, so we can start our question numericals from tomorrow. Rescue, escape, and reviving apparatus. Okay, so normally a person doing the normal work, breathing at the rate of the 15 bath per minute. Okay, this is the normal situation, and he will consume 1.5 liter oxygen per minute. This is the normal scenario. If a person in the normal scenario, he will take 50 breath per minute, as well as or consume 1.5 liter of the oxygen per minute. ठीक है. But in the sometime suppose this is your phase and your working is going on here in this district. So this roof fall anything, your person will be in the one sided roof is collapse and you have to travel more, and your ventilation is disturbed, then these apparatus help you to rescue from the place. So so up in the emergency these apparatus help you and provide you, so you can get 1.5 liter oxygen per minute, because you need in the normal scenario these quantities. Okay, so there are some instrument. First we will see proto cell containing compressed. So first I want to clear that I will just cover those information which are mentioned in the ekegoi, because uh, as I told you that our main focus is to complete ekegori. If I deviate, then it is time consuming, and I think you have other classes, or you have a recorded class, so you can cover your if I if any information you need more than whatever I am teaching, then you go for another reference. I'm just covering ekegore and it will very helpful you, because the gate examination or in the numerical section ekegore has covered sufficient information. So first is the proto self contained compressed oxygen apparatus. Okay, so these are two types. First is a proto mark 4 and proto mark 5. Suppose if this is the your proto self contained compressed oxygen apparatus. So it is a closed circuit. I think you know what is the closed circuit. Closed circuit, that means the air in it, um, you don't take the oxygen is this is your apparatus. It does not take oxygen outside from the outside of this apparatus. It make inside it. So sometimes it may be chemically formed, or sometimes it is stored in it. Okay, so closed circuit operator, sometimes you will see that some of the apparatus you will see that they are open circuit, some of them are closed circuit. So the proto self contained compressed oxygen apparatus is closed circuit, you just need to know. And second, it is the store 300 liter of the CO2 compress at the, don't need 150 kilogram, but you just need to know 300 liter, up to 300 liter oxygen you can store in the container of the proto cell contained compressed oxygen, because compressed, you compress that oxygen so you can store in it up to the 15 kg, and you can use up to 2 to 2.5 hours you can use. Okay, feeding rate is 2 liter of the oxygen, so 1.5 to 2 liter of oxygen per minute you can, it can be feed. So just remember 3 4 points. First, it is a closed circuit. Second point is 300 liter of oxygen it can store, and third point is it can feed 1.5 to 2 liter per minute, and fourth point is it can work up to 2 to 2.5 hours. Second prototype Mark 5 is similar closed circuit 300 liter, and but its capacity is 1 hour to 2 hour use of capacity. Just difference is the capacity. Third, you will see Draeger self contained compressed oxygen apparatus. Draeger self contained compressed oxygen. It is also closed circuit. Okay, so you can store in this tank oxygen, you can store in this container, and you breathe in the emergency. Okay, so it is the closed circuit, so you take the oxygen and you don't take oxygen from outside, because the ventilation is in collapse, ventilation system of your mines is collapsed. So in that environment or that situation, you use Dagger self contained compress. So it is closed circuit, and it is a working is 4 hour, up to 4 hour it you can use it. And so the timing is more, then you can store the more oxygen. So approx 400 liter of oxygen you can store in it. And a feeding rate we have seen in the normal situation, you if you can breathe up to 1.5 liter per minute. So another system is chemically oxygen breathing apparatus, like its name showing, chemical oxygen. So in it you don't store oxygen, you use CO2. It consists canister where the CO2 is stored. O2 needed to breathing produced from the chemical reaction. So in this apparatus, chemical reaction will going on, and it will make, after when CO2 and water reaction, it will form oxygen. Okay. And it is chemical oxygen breathing apparatus is also closed circuit operation, and you can only use it for the 30 minutes. So for the small or the half an hour, if you want to take a apparatus for your safety, you can take that chemical oxygen breathing apparatus. But if your mines is very deep, then you need big capacity apparatus. Another is a self rescue breathing apparatus. It is made up of the France self rescue breathing apparatus. It is also closed circuit operations, and you can use up to 1 to 4 hour. Use depend on the work performance. Why work performance? What is the mean of the work performance? Suppose if you are standing in the underground and the ventilation collapse, then if you are sitting or standing in that environment, the you can use for the more hour. But if you are running, then you will breathe more, you consume oxygen faster. So in that environment, in that situation, the capacity will be utilized faster, so working hour will be reduced. So you just remember the working principle of these apparatus is, working principle is AUR SAR 30. Chemical oxygen breathing apparatus is also working principle is AUER SAR 30. Okay. Now self-rescuer. Self-rescuer Self-rescuer is open circuit operation. Open circuit, as I told you. So this is also open circuit. You breathe air from the outside environment. So it filter. Suppose you have a lot of fume and gases in your environment, but O2 also present. Then you use gas mask or the self-rescuer, so it can filter oxygen, so you can breathe in that environment. So this is the open circuit. Self-rescuer is open circuit, and O2 is not supplied by the self-rescuer, as I told you, because it is open circuit, so you can take O2 from the environment itself. So you don't need if you it is open circuit, then you don't need a capacity tank, so its weight will be reduced. It work on the principle to convert the carbon monoxide to carbon dioxide. So if in the environment carbon monoxide is present, then you use self mask, so it will convert CO to CO2, and CO2 is not harmful as much as carbon monoxide, and it is used to escape during the fire. So if the fire is present in the any environment, you use self rescuer, so it will convert CO into the CO2, and you can come out from that environment. So you can use self rescuer where the carbon monoxide present up to 2%, and you can sustain in that environment up to 1 hour. Why 1 hour? Why not more 1 hour? Some filter are in that self rescuer, so that can be only convert CO2 carbon monoxide to CO2 up to 1 hour. After that, the filter may be damaged. So that suggest to use self rescuer up to maximum 1 hour. Then we see gas mask. So gas mask is also based on the open circuit, so that means you can it is also not provide oxygen supply, so its weight will be also lesser, and its principle is also carbon monoxide will convert into the carbon dioxide, and Hopkelite catalyst is used. So in these you can use Hopkelite. They use Hopkelite. So Hopkelite will convert CO into CO2. Similar, both are similar. So don't just reviving apparatus. I think you have seen in the hospitals like that set structure, and its principle is pulmometer. Just remember pulmometer. They can ask you the principle also. So it is used to supply pure oxygen, and कोई बेहोश हो जाता ना, बेहोश हुए आदमी के लिए O2 सप्लाई करने का. You can see and you have seen in the corona they are using the reviving apparatus. Okay, so still if you have any doubt in, now come to the airflow through the mines opening. So there are the two types of the flow. First is the streamline, and second is the turbulent. You can say laminar and turbulent. I told you whenever I was discussing. So there are two types of the flow. Okay, streamline and the turbulent. So how you will find out these flow, or the nature of the flow is governed by the dimensionless parameter which is known as the Reynolds number. It will represent with the RE. So I think I told you, if the lesser than 2000, it will known as the streamline or laminar flow, and if it is the more than 2000, lesser than and greater than, then it will known as the turbulent. Okay, so these formula you should remember. So Reynolds number, that means velocity of flow multiply with the dimension of the diameter of the duct divided by viscosity. This is your Reynolds number. Remember this formula. When we solve the question, it will be helpful for us. So as we know viscosity, you can also write mu by rho. What is mu? Mu is this is the kinematic viscosity, and this is the viscosity, and rho is the density. This is the kinematic viscosity. Just remember this formula. Tomorrow I think we will start the numericals, so it will help you. And the pressure drops in the mines. You what formula you need? Pressure difference, that means del RQ square. First this formula you have to remember. Delta P, that means difference between the pressure, is equal to RQ square. What is the R? So R is the resistance, Q is the flow in meter cube per second. Okay, and delta P is the pressure drops, pressure difference you can also say. Okay, so one formula you should remember this. Second formula, second formula you have to know about it. Delta P equal to Ks Q square divided by AQ. Okay, and as you know, Q बराबर AV, A means area, and V is the velocity of flow. Okay, so this formula, and this formula, where what is the K? K is the coefficient of the coefficient of friction, coefficient of the friction F by 8. Just remember, when you will solve the question, it will required, है ना? On the based on this formula, they may ask you in the question. Not, I am not saying that in the SCCL examination, but if you are also appearing in the gate examination in the next year, it will also benefit for you, or in the another exam, or the mining officer, or any exam of the mining. So please remember, they ask this type of question. Coefficient of the friction, that means F by A. And what is the F? F is the resistance coefficient. We will see when we will solve the questions. Okay, KSQ square by AQ. So when you use in it, another formula will come, delta P, which will be KSV square by A. So don't need to remember this formula, just remember these three formula. So it will another formula you can drive. Okay, pressure drop in the mine airway, we have seen what are the formulas. Pressure drop in the mines, please go and today revise whatever I have teach you and whatever we have discussed in the ventilation sections, all formula, all theories. And if you can read, then follow DJ Deshmukh, also read DJ Deshmukh also. So साथ साथ में आपका वो भी रिवाइज होता रहेगा, ventilation part up to the ventilation. Okay, and shock loss at area changes and the bend. Shock loss, I think you know, if you are in a district and if district turns on 90-degree, so your air will also turn. So turning, there will be air loss. So shock loss at the area changes and the bends, shock loss will be x multiply rho v square by 2. Where, what is the rho v square? So x is the shock factor, and rho is the density, and v is the velocity or flow. Okay, so remember this formula, x rho v square by 2, which is the shock loss. What we have seen, first we have seen airflow through the mines opening, we are uh, reading. So nature of flow, how you find out the nature of flow? With the help of the Reynolds number. What is the Reynolds number? Reynolds number, that means Vd by V. V means velocity, D means diameter of the duct, and small v, that means kinematic viscosity. Then we have seen the pressure drop in the mines. Pressure drops in the mines, that is delta P equal to RQ square. What is R? Resistance. What is Q? Flow. in meter cube per second. What is Q? Q is A by V, A into V. A is the area, V is the velocity. And what is delta P is also equal to the K as Q square by A cube. K as Q square by A cube. K as Q square by A cube. K, I told you, coefficient of the fraction, which is also equal to F by R, F by 8. And what is the S? S is the area of the surface area. And surface area, how you will find out? Suppose this is the your duct. This is your duct or circular duct. I don't know which type of they duct they will provide, and its length, it is the length. Okay, or suppose it is circular, then it will be its length. It is the length, and it is the perimeter. Perimeter, that means this is the perimeter. That means you have to add all the dimension, and about its perimeter 2 pi r, circular opening. So for the surface area, you have to multiply length into perimeter, length into perimeter. So as this is surface area, length into perimeter, and A is the area. A is the area of the cross section duct. Then we have seen the shock loss at the area changes and the bend. Shock loss is the x rho v square by A. X rho v square by A. And equivalent resistance. So please focus, you may confuse in this formula, because we have seen in the electronics or in the 12th class, you have seen that 1 by r equivalent equal to 1 by r1, 1 by r2, 1 by r3, like that. But here in the ventilation, if you want to find out equivalent resistance in the number of roadways which are parallel, parallel means if you are here and your when these are your districts which are parallel, like this. So this, if this is r1, this is r2, this is r1, r2, r3. Then if you want to find out r equivalent, then 1 by r equivalent, 1 by root r equivalent equal to 1 by root r1, 1 by root r2, 1 by root r3. Okay, just remember, and that is how it's depend कितने हैं, उस हिसाब से आप कर लेंगे. Or if they are in the series, that means if your districts, if your flow, and you this is your second and this is the third. If r1, r2 and r3, then they are in series. So for the r equivalent, for it will be r1 plus r2 plus r3. Okay, so just remember, for your ventilation, you will use these formula. Don't confuse air power. So what is the power? Just remember what is the power. Power, that means if you multiply pressure into velocity, air power, that means delta P into Q. Delta P we have calculated RQ square multiply Q, which means this will be RQ cube. You can also write down delta P, which is equal to Ks Q square by A cube into Q. It will also will become Q by A cube. So you can use that formula also. Just remember this formula, and another formula you already remember, so you can calculate. And air power direct formula is air power direct formula. If you want to revise or remember, whenever you revise and remember, recall, you just remember that air power is RQ cube, where Q, you know, quantity of airflow, You also know delta P is the pressure drops. And in the equivalent orifice, इक्विवेलेंट orifice मीन्स अगर मान लो आपको छोटा सा एरिया, the resistance of the mine's area can be expressed in term of the equivalent orifice. That means ये पहले तो ये फॉर्मूला गलत है. 1.2 इंटू क्यू डिवाइड बाई, ये भी नहीं, 1.2 डिवाइड बाई रूट आर, ये गलत नहीं है, बस जस्ट इंफॉर्मेशन इज रॉन्ग. जो यू जस्ट नीड टू remember that it is the, this formula is up to this 1.2 q by root p, but it is simple to revise a बराबर 1.2 divided by root r, and you already know that in the last delta p or p equal to rq square. So from here, if r, you can write p by q square. So when you put here, it will become 1.2 root p and q. So just remember this formula, a बराबर 1.2 divided by root r, है ना. So they will ask you the parallel ventilation districts. So you have to find out r equivalent, and it r equivalent you will put 1.2 divided by root r, and that way you can find out a, that is the equivalent orifice. And all the value, you know what is the a, area of the equivalent orifice, and what is q, quantity of air, what is the p, pressure, r is the resistance, and the rho is the density, which is the 1.2 kilogram per meter cube. Okay, and nature and the mechanical ventilation. In this formula, you need two formula. First is the nature of ventilation, and both are the similar. So one of the formula, if you know, another you can calculate. So these formula you know it. We have seen NVP. I think D बराबर rho D, rho U and G. This is the downcast. This is uppercast. Rho D, that means downcast density, and rho U, that means uppercast density. Okay, so rho D means density of air in the downcast shaft, and rho U is density of the air in the uppercast. So it will be BD minus 0.378 ED into 1000 divided by 287 into TD. They can ask you the direct question based on it, or sometimes they can ask you what is the density of the downcast shaft, one of these value, or the density of the upper cast. So what is the NVP? So we know that NVP is D rho D, that means density of the downcast, density of upper cast. When you subtract both of these, you will get this formula. So I am not going to drive the formula. Just remember these two formula, which will help you in the question, because they will ask you directly what is the NVP. Okay, NVP means G, this is the gravity, D is depth, B, and TU minus TD into 10 to power 3, temperature of upper cast, temperature of downcast. So that way we will find out. He will provide you all the information. Just remember this formula of NVP and density of the air of the downcast shaft, or density of the upper cast. Now motive column. अरे यार motive column तो कुछ नहीं होता है. I think rho G H you have seen. यहाँ पे if the rho G H is P we are talking here is NVP. So NVP is rho G H. So here H equal to NVP divided by rho G. is the formula. So motive column is the height of the air column to the downcast shaft, which causes the NVP termed as the motive column. So that, so what we have seen up to this, first we have seen the formula of equivalent resistance, how you will found for the parallel resistance, equivalent parallel resistance, and for the equivalent resistance for the series. Then we have seen the air power, which is the RQ cube. Then we said we have seen the equivalent orifice, which is 1.2 divided by root r. And then we have seen the nature and the NVP is G GdB Tu minus Td, अरे यार वो T2 minus T1 you can say, or T uppercast minus T downcast into 10 to power 3 divided by 287.1 temperature of uppercast multiplied temperature of downcast. Then we have seen motive column, which is NVP divided by rho g by density of the downcast into z. Ventilation survey, why we do, because ventilation is very important in the underground, and it is if the good ventilation will occur, your worker can work efficiently. So you will read lot of about the ventilation survey in the theory section. So I will give you the what is the Indian mines regulations. So if you are working the coal mines in the gassy mines or gassy mines, you have to do a survey within the 40 days. 40 days you have to do the survey, measurement of the ventilation or quantity measurement you have to do. But if you are in the non gassy mines in the coal field, you have to do 30 days measurement. And the measurement should be made in the main intake, main return, the speed near the starting point, ventilation district. There are various points where you have to measure the air quantities, and you have to not only measure the air, but you have to also measure the temperature, humidity, and other environmental condition in the 30 days. So just remember the 2 3 points of these paragraphs, that if the mines is the gassy mines, then you have to calculate the data of the various ventilation data like temperature, air quantity, humidity on the 14 days basis. If you have the non-gassy mines, then you can do the survey in 30 days. There the measurement of the velocity in the airflow. There are various methods on the base of which you measure the ventilation. First is the smoke cloud method. Suppose this is your district, so airflow from this district. So if you if you are in this method, when time taken to cover a smoke from here to here, suppose this is distance s, is known as smoke cloud method. That means time taken to cover particular distance as smoke has to recorded, and velocity can be calculated. So in the district, so smoke will be travel. So if we travel as distance, then you will measure the velocity and convert velocity, that means distance divided by time. You have read v बराबर दूरी बटा समय, that means distance by time. From on the bed you will find out. Another meter is a hot wire anemometer. This sometime hot wire anemometer, this is a very sensitive instrument for the measurement of the low air velocity. It can measure low air also. And this is a digitally hot wire anemometer. Another is vein anemometer. Vein anemometer look like this. So it simply give the distance traveled by the vein set in the anemometer at the particular duration of the time. The velocity thus the calculated indicated indirectly by the dividing the distance by the miles. This is the Van anemometer. This is the velometer. Velometer is also double pivoted spring balanced aluminum well. Just look like the names. What is velometer, Van anemometer? They will ask you what is the velometer is. They will give you the three, four names, and they may ask this name is related to. Okay, so I whenever I see a name, I try to find out a image on that, so you will get the basic information about that instrument. And this is the pilot state tube. Pilot state tube, if you put, the air will flow and this will rotate. So on the basis of it will give you the idea how much velocity. And relative humidity we have already discussed. So this is, if the 20, less than 20, then you will consider 9 factor. If the 20 to 25, then you will consider 8 factor. And if the more than 25, you will consider the 7. So formula is 100 minus factor into dBT, dye bulb temperature, and wet bulb temperature. Okay, this will give you RH. So our theory section for the ventilation we have covered. Tomorrow onward we will start to discuss the numericals.
To watch the complete video, download Mining Gyan 2.0 app from the Play Store and enjoy seamless learning with Mining Gyan 2.0.